Good afternoon, everybody. Welcome to Robots and Red Tape. As always, I am your host, Nick Shutt. Happy to have my friend Jon Conrad here today. Jon, how are you?
I'm good. Glad to be here.
Thank you so much for coming, man. For everybody that doesn't know you yet, do you mind just giving folks a little bit about yourself, your background, and kind of how you got here?
Yeah, most recently I was at principal AI researcher at Amazon. Um, and my most recent projects were working on developing curriculum for Amazon's vice presidents and directors to bring them up to speed on AI and machine learning. One of the fascinating things I learned is that Amazon has great leaders, and the vice presidents, they're highly educated, they're super smart, they know their businesses inside and out. But for a lot of them, AI was kind of coming out of left field. It wasn't something that they thought about or were trained in, and so they had a lot of questions. And it's hard for someone to differentiate between kind of magical stories and what AI can actually do.
Hmm.
And seeing that within Amazon, I thought, wow, what is it like outside of Amazon, right? Where we don't have all these natural benefits. You're not a tech company. And so I left Amazon in July, partially to, meet more companies and talk to them about what AI is and how to invest in it.
It's fantastic, man. Great time, great time to be doing that, especially considering your background at Amazon and elsewhere prior to that. What was it? Out of curiosity, the folks you were teaching at the VP and director level, were they primarily in the technical space, or were these programs designed for folks that, were, say, running Amazon's warehouses, logistics, things like that as well?
Yeah, so AI can touch pretty much all of Amazon's businesses, right? Amazon has roughly 1.6 million employees
Hmm.
in all kinds of different aspects of business. There were definitely vice presidents who had PhDs in AI, right? So
Hmm.
those highly technical VPs, they didn't need to talk to me. But if you were a marketing person or logistics, or you're trying to manage, say, Whole Foods or one of those other divisions, yeah, you perhaps had very little exposure to AI. And yet it could have a big impact on your business.
Yeah, no, absolutely. Yeah, I know here we're talking about today machine learning versus automatic machine learning or auto ML. If you don't mind, would you explain to folks who don't know, who are maybe more like the folks at Whole Foods as opposed to the PhDs in AI research, what machine learning is?
Yeah, so machine learning, well, I'd like to start off with artificial intelligence. So
Mhm.
artificial intelligence is this broad goal of trying to create something that's indistinguishable from a person.
Hmm.
And there's a variety of ways you could achieve that goal. One of the ways is through math and computer science, and we call that machine learning.
Hmm.
Um, these the systems that we refer to as AI, like what ChatGPT, released a couple years ago. Those are really advanced, very complicated systems. Fundamentally, they're machine learning, right? They're sitting on top of math and computer science. But the goal overall is to create something that can be indistinguishable from a person and make hard decisions like a person could.
Hmm. Absolutely. And how does a traditional ML deployment differ from an automatic one or an automated one?
Oh yeah. So AutoML it, it's a fascinating story, I think. In fact, it had a pretty big impact on my career trajectory. So, like most machine learning AI researchers, I was picking training data and building models and measuring their performance and shipping them. Um, and you notice that there are these kind of you go through the same steps every time, right? You do this
What are
step.
the
Oh,
You give it
like
a high level for folks?
yeah, high level, like preparing your training data, picking which kind of model might be a good fit for it, building some test models, measuring their performance, making changes to the model, trying to figure out how to get better performance. There were some pretty consistent steps, and a lot of them involved analytics.
Hmm.
Ideally, you would like train on a bunch of different um, algorithms, like not just say random forest, but you would try vector machines and you try all these other different things, neural networks perhaps. Um, so when I was introduced to AutoML, there were kind of two streams of thought going on. The first one was, oh, we can create a model that's able to look at the data, look at the goal, and kind of strategize on the best way to do it. We could call that like the smart AutoML version.
Hmm.
Um, a team at Amazon took kind of the throw spaghetti approach to automatic ML. And their idea was, let's not pick. Let's just take our training data and throw every kind of model at it. Train, say, 13 different types of machine learning algorithms on the data, and then gather those results
Mhm.
and do it again. So it's an ensemble of models.
Mhm.
And if you look at it, um, I would never do this as a human being. It's just too much work, right? You got to set everything up, and you got to move all the data. And usually it's a lot of work to do a couple models. 13 at a time is a lot to ask for, but to double it and do 26 or 27 models is just a huge amount of work. Until you basically write a Python script that's doing it.
Mhm.
So they had this idea that, okay, well, since the steps that we follow are pretty regimented and
Mhm.
the decision points we make are pretty well defined, and the metrics that we want to measure at different points are well understood, what if we just did everything? Let's just do it all.
Mhm.
And over time, they added additional algorithms, they added additional performance metrics. They figured out really good defaults for the algorithms. And so in some ways it's the dumbest approach because it's like we're just going to throw spaghetti at the wall, see what sticks. But
Mhm.
at the same time, the performance turned out to be fantastic.
Makes sense.
And so traditional machine learning, you'd have some human beings that spend weeks working on it together, trying different things, having meetings about their performance, whatnot. AutoML, especially AutoGluon, which is the project that came out of Amazon, you get your training data, you run it, you go home, come back after the weekend, and you've got this world-class model. It was really quite shocking. And so when I looked at that, I thought, oh, well, there's no job for me now,
Mhm.
right? I It's done. Like, we could solve if it's a regression, if it's classification, or it's time series, we can get a really great model over a weekend. I should go find something else to do. And so that's when I started moving into more AI and neural networks.
Okay.
Yeah, that's basically what it is. It's a remarkable technology. Um, and it has some additional benefits that'll probably come up as we keep talking.
Absolutely. And so just so I understand, essentially the auto ML, instead of having to spend weeks and weeks and weeks running, building each model and creating all the training data, customizing it for all these different algorithms that you're going to run, essentially it's scripted running using a script to run it more or less, and run multiple models all at the same time. And it was able to do that because you're able to do that, not, probably not on some edge cases, but for more of the more commonly understood ones, you're able to kind of run through this. Is that right?
Oh, no, I mean, you can do edge cases too. So
Okay.
there's still work on the training data side. I mean, you still need to be smart about figuring out this is the data that relates to our goal, and you have to have nice, clean, say, labels for what you're going to get to. But so that's still work. You got to do the work on kind of the two endpoints. But in the middle, um, because you're throwing it's an ensemble. So you can think of it like a choir, right?
Hmm.
And so in the first row of the choir, you've got 12 models. They're all given the training data, they're trained, and so now they're really good at it. But then behind them, there's another row of models, right? And so that row of models, they get the benefit of the training data, but they also get the benefit of the best answers from the front row,
Mm,
right? And so
okay.
then these models are all trained and they output their data, and then you've got one final model
Hmm.
that can see everything. And so it's trying to figure out, okay, um, within this range of values, it turns out the random forest models are doing better. Within
Hmm.
these range of values, it turns out decision trees are doing better, or XGBoost, right? So the final model can see all of these results and make a final choice, which means that even when there's edge cases and weird data, one of your models is going to be good at that, and this ensemble is going to allow the fact that these types of models perform best to really shine.
Hmm.
It's um, yeah, it's a remarkable idea. It's a lot of compute, right?
Hmm. Yeah.
But you end up with um, a state-of-the-art model very quickly. And often time is the important thing, right? And you don't necessarily need, a PhD scientist to be working on this thing. You need someone that really knows their training data well, really knows their labels well, and can make sense of the voluminous reports that it produces for you to help you understand why it made the decisions it made.
Okay, that's fantastic. And as you said, I mean, it's taking deployment times down from weeks to days.
Yeah, yeah, development times just disappear, right?
Mhm.
Whereas it would take me maybe 3 months to build a really nice state-of-the-art model. Yeah, it could be a weekend.
Okay, that's incredible. Yeah, it's
It's
incredible.
crazy.
Yeah, and yeah, it's interesting that yeah, as somebody that sits on the user end, one of the things I used to do before a lot, because I use AI, generative AI a lot in my job for just different aspects of it, is I would take an answer from say a Gemini and feed it into ChatGPT and then back and forth until I had something that I thought was better and just taking the better answers out of each one. But it sounds like essentially it's doing that, but at a in a far different way, at a far higher level, right? Where you're
Yeah,
essentially using other models to train other models and then giving another model the opportunity to review everything and kind of see it all, right?
yeah, yeah. So you were by hand doing an ensemble.
Hmm.
Exactly. And random forest models are essentially an ensemble because it's a forest of decision trees, right? And so you can think of each one of these trees as being one of these voices in the overall chorus of the model, which are
Hmm.
then combined into a final decision, right? So the AutoGluon team, they took that idea and they expanded it.
Okay.
Uh, Yeah, it's quite remarkable. They did a fantastic job. And
Yeah.
it's like 3 lines of Python to
Mhm.
go from my training data to a world-class model. That's
That's incredible.
crazy.
That's incredible. That's also reinforces that the simplest solution is often the best one, right? Like you don't need to make it overly complex if you only need a couple lines of Python to do it. Obviously, all the underlying work of writing and creating all those models is already done, and that's a sunk cost, but that's already a sunk cost across the board, right?
Yeah, yeah. I mean, there is an enormous amount of code that gets run,
Mhm.
but it's all hidden behind this very simple interface. And
Absolutely.
and they did leave behind plenty of little switches. If you do want to play with it, you can play with it and adjust things. But even so, the decisions that they made up front are really good. The basic parameters you should start with, and you'll be very surprised at how good it is.
Absolutely. Outside of the time to amount of time that you're going to save by using something like this, what are some of the other key benefits for organizations looking to implement this for business?
Yeah, well, um, sitting inside of Amazon, when I saw these types of systems, I realized that that the generative AI systems that we were building, uh, they were great at words and finding facts and doing RAG and those kinds of things. Um, but they would be a lot more powerful if, instead of writing all the code, they knew to just send off data. Like they could prepare training data or point to training data and send it off to a system that was just sitting there ready to do AutoGluon, right? And so then you have uh, uh, generative AI models in kind of an agent type of design that are able to do amazing things, right? They're able to do classification, regression, time series, um, you know, very fast with a lot of complexity hidden behind the scenes. Um, and I thought that's super powerful. That's probably where I would like to see this stuff go. It becomes just another part of a larger generative AI solution.
Hmm. Absolutely. Absolutely. And what kind of data do you need? And then how, because I know you talked about a lot of upfront work still with preparing the training data. What kind of data do you need first, and second, what kind of work do you need to do to prepare that and clean it to run an auto ML like this?
Yeah, so you're gonna give the model tabular data,
Hmm.
right? And it's excuse me, and it's gonna have a column which is the label that it's going after. Um, but the first step that the AutoGluon takes is to look at columns that contain things like, well, first of all, it tries to figure out what the columns are.
Hmm.
And so let's say there's a column which is state, and you've got Virginia, Nevada, you got a bunch of states listed. There, it would say, okay, these are sentences, these are categories, right? So it would say, okay, I'm going to classify this as a category, which means not all of my 12 models can use that, right?
Mhm.
It would also look at text and say, okay, this looks like text. Maybe it's the text of a review, and it's
Mhm.
going to break that apart and do kind of all of that work that you would do as a data scientist, so your non-generative AI models can make sense of it and use it. Um, an obvious thing for it to do also, and I don't know if that's in the current version, but I think it's an obvious thing for them to do, is build into AutoGluon embedding models. So now you have, say, a very sophisticated embedding model, say Claude's embedding model, and it's able to actually pull out the meaning of the text and provide that as a vector to all of the different models. The beautiful thing is, um, I need to make sure that my training data makes sense, that it's accurate, that responsible AI concerns are taken care of. There's all that work that you have to do anyway. But um, with each new release of AutoGluon, you're gaining capabilities, like say that embedding, right?
Mhm.
And so you can just retrain your AutoGluon model, and the performance is going to be improving over time. And it's
Mhm.
taking care of things like missing data and ranges of values that are extreme. It's doing all that kind of work behind the scenes for you. And so there is a lot less data cleaning than you would have had to do on your own. It's a
That's
big
fantastic.
time savings.
Yeah, absolutely. And do you have any specific examples of use cases that have, where where first, where you've been able where you either have been able to speed up, the deployment of these models specifically, and kind of how what would that, what are some examples where or how would that relate to like a tangible business result, right? Um, can you give some teeth and some thought behind some situations where this could, either save lives or save a lot of money for organizations
Yeah.
overall.
Um, so I'll give you examples of classification. So an interesting thing to classify is, is this customer or is this user trying to do something naughty?
Hmm.
So at Amazon, those kinds of things are, sellers trying to abuse other sellers, or buyers trying to rip off Amazon or rip off sellers, like those kinds of things, right?
Hmm.
Those models are fairly complicated, and they might have hundreds of columns of data.
Hmm.
Um, and so that's a model that Amazon has worked on in one way or another for a long time.
Yeah.
Um, well, AutoGluon makes it, so you have this highly, human-tuned model. AutoGluon comes along and can build you a new model that's very competitive with that original model, which is crazy, right? So you have years of experience building this model, working on the data and whatnot. And then over here, you've got something that you ran a script of 3 lines, and boom, it's very close to the same result. So yeah, the classification is a great thing, and you use classification for a wide number of things. Regression, of course, is predicting some sort of number. And
Hmm.
so, um, Amazon goes through a budgeting process like all big companies, right?
Hmm.
And so we have a place very smart, very good at their work. They know SQL in and out. They know the tens of thousands of tables that Amazon runs on top of. And one of their jobs is to prepare the data so they can make projections about next year.
Hmm.
How much are we going to spend? How much are we going to sell? How many data centers do we need? How many fulfillment centers do we, how many employees do we need? Like, right? They make all these numeric predictions. Um, and honestly, a lot of those initial predictions just come out of Excel, right? You get your numbers and you do your regression in Excel, and like you're good, right?
Hmm.
And the people receiving the report, I think they understand that, right? They know, and they've gone through this process many times. They don't expect the numbers to be dead on, right? They're getting a
Hmm.
feel for the numbers, right? So they're not. Um, with AutoGluon, you really could get a really good prediction,
Hmm.
right? In fact, at one point, I was responsible for all the data that was being used on Amazon devices worldwide. And we would have a meeting once a week where we would sit down and look at all this information about like how many people are coming from search and how many people are coming from, um, you know, um, referral sites and those kinds of things. Um, and we would produce a report, and we would sit down and we would debate the report every single week. And initially, the report didn't have anything about how did this compare to the prediction. And it really didn't have anything that said, this is what we predict is going to happen in the next week by the next meeting, right?
Hmm.
That's machine learning. And it was such that you couldn't really do it in Excel, right? It was too complicated, too sophisticated. The error bars would be too big if you did it in Excel. But you drop that kind of data into AutoGluon and you get a model or maybe a dozen models for a dozen different things in the report. And suddenly your business leaders have much better insight into what's going on,
Hmm.
right? They rather than debating whether the drop of 0.12% was significant or not, they could say, "Oh, how did it compare to the model?" And the model, which they have seen week after week is reliable, the model says that, oh, they was expecting uh, 0.09,
Hmm.
right? So they're like, oh, okay, well, actually, we did well. Like there was things that we did that actually worked, or the flip side, like the prediction was much higher than what we were. Let's talk about why that happened and figure out what's going on. So that's a really powerful thing. And then time series, of course, you end up with, especially in business cycles, you have these seasonal effects and whatnot, right? And you can't do that. Well, can't do that in Excel without like an advanced plugin or something, I suppose. And you could do it like you could grab a scientist who knows R. Like we have a lot of economists within Amazon. Grab an economist, have them do a big model in R. Pray to God that they don't change teams or like leave the
Hmm.
company because with R isn't exactly the world's friendliest language.
Yep.
Um, but they can get you a time series model. Or you can organize your data, do a time series model in AutoGluon, and kind of a lot of those concerns go away. You end up with a world-class model, helps you out, tells you kind of what's going on, when what to expect um, at a much higher fidelity. So a lot of this has to do with the fact that you can downscale the skills required to get to a machine learning solution,
Hmm.
right? You know, within Amazon, one of my jobs was trying to hire people, right?
Hmm.
And while I was there, I interviewed over 500 people, so I probably saw 2 or 3 thousand resumes, right?
Yeah.
And it's hard to hire machine learning people
Oh yeah.
because they're so well. Even a few years ago, they were, there was a lot of competition for people with these talents, and it was hard to locate them. And they had jobs and they were happy, and all that good stuff.
Hmm.
Um, But if I could take someone who has SQL skills, that we could sit down and explain this to them, explain how the different metrics work, maybe provide them with an easy way to ask questions of, say, someone who has a PhD, I could suddenly take this entire class of employees who couldn't create a model on their own, but they are perfectly capable of organizing the data, the labels, and running the model
Hmm.
and asking good questions. And so suddenly we could push machine learning way down in the organization, right?
Yeah.
It wasn't going to be the specialized team kind of in the building over here that you could never get a meeting with. It was going to be basically every team in every place.
Hmm.
And I think that is the real advantage. Like everybody's much better off with an excellent ML model at hand than waiting a month or two, a year or two to finally be above the line so you're allowed to, ask the machine learning people to do.
Hmm. Yeah. And uh, first, I appreciate the in-depth explanation, John. And second, I agree with you when you look at hiring ML talent. I have sat in that space and continue to sit in that space a lot, and seeing the difficulty a lot of people go through. And let's also be clear that Amazon first has the cachet within the or the rep cachet reputation within the tech community to attract some of the best and brightest that a lot of these smaller organizations just can't get access to, and frankly, second, Amazon can afford them, right? I know of multiple. I know one of the CDAO offices here locally in the DC area that does a lot of data analytics for one of the major government branches. Have been having trouble hiring and retaining these folks because the GS scale is not competitive with what Amazon can pay. And I know a couple of people, one in particular, I heard a story a couple months ago. This woman got hired, brought on, and 6 weeks after she started, had to pay back $100,000 signing bonus because Amazon came in and offered her like $600,000 a year or something like that, right? Yeah, and being able to democratize this and being able to run a lot of these sophisticated models without needing that level of expertise is absolutely a game changer.
Yeah, yeah, it's a big deal because well, the other thing to know is that if you use AWS services, there
Hmm.
are these really nice AWS services that will build a model for you, right? Those kinds of things. They are using AutoGluon behind the scenes, right?
Okay.
So some of you, if you're using those things, you've already been using AutoGluon, you didn't realize it. Another
Hmm.
thing to know is that AutoGluon's open source. And so if you have security concerns, you need to go through some sort of security audit. All the code is there. You can copy it down, you can inspect it, you can decide we're not going to take any future changes unless, we, green light those changes. Great. Like that's all there. You want to run it in your own data center? It's an open source project. Run it in your own data center. It runs fine on a laptop.
Uh,
Slowly, but it runs fine, right? And
yeah.
so yeah, all of those things are, especially for, I think for your federal listeners, I think those are big advantages. I think it's a really good thing for them. Okay, but here's kind of the secret sauce. This is what I realized that, oh my goodness, this ensemble is a lot smarter than I thought initially. Remember, so what happens? The very first layer is like 12 models, 15 models, something like that. They get your training data, they get trained, right? And they've got really good initial parameters because the team has done tens of thousands of models and seen this is how random forest works best. So you, they get trained and then they output an answer, right? And then there's that second layer that's going to use that as part of their input.
Hmm.
But here's the thing. All of the performance data is provided for every model on every layer.
Hmm.
And so, what I tell people to do is use AutoGluon, build the ensemble, and get it into the market, right? Because that way, within a week, you've got something in production and you're getting real information about its performance in the marketplace. But then, that's when someone who has more experience with machine learning, they also have access to all of those individual models in that first layer.
Hmm.
Those individual models, they didn't receive any information. The second layer you can't use because they receive information from the first layer. But
Hmm.
those first layer models, they're trained. They're ready to run independent on their own. And
Okay.
so if what you want to do, because like I said, AutoGluon initially it's large, which means it's pretty slow relative to, say, a decision tree. But you're in the market, so that's great. So that's up and running. You're getting real data. You do a second pass and you look at each of those models in the first layer and you say, okay, here's how this one performs. We're going to just go on the drive and we're going to pull that off and we're going to use that model and we're going to see what we can do to maybe improve the parameters, do some other things. Maybe we take two of them together and have a model that joins them. So you have a tiny ensemble. It's like all of a sudden your RAM requirements, your CPU requirements, and your latency go way down because you've got this one model. And you've already got all of the performance information about it. So it's
Hmm.
not like you're going in blind. Um, I think that's a huge benefit, right?
Hmm.
Especially in a business and in tech, it's important to move quickly, right?
Hmm.
Because what you really want to know is what happens when real customers see it and what happens when we make real decisions on it, right? You need to get it into your A/B experiments. And so, like if I can have it train over a weekend and then spend the entire next week deploying it into production so we can run an experiment, that's great. And then I can spend the week or two that we're in the experiment phase picking out the best model I want and seeing what I can do to make it just a little bit better. So now I've got another model I could follow up with that's faster, smaller
Hmm.
models.
Right. So you can start with all, in this case, 20, 24, 25, 26 models, and then scale it down to just one, but you can only play with the first layer of them. You
Only
can't.
with the first layer. Yeah.
But absolutely. Out of curiosity, why are there two layers? Why aren't there more?
Oh, you can. So that is actually one of the parameters. Like if you want to go nuts, you can, have 17 layers, which is start to be a really big like generative AI type scale model, right?
Hmm.
Um, I've never gone beyond two because we'd hit our performance goals and we were happy. But you could go beyond that.
Are there, can you think of reasons why you would?
Um, it, so similar to neural networks, right? So as you add layers to a neural network,
Hmm.
what you're actually doing is you're adding additional understanding of abstractions,
Hmm.
right? So like, well, what happens in these cases when these unusual circumstances are involved, or understanding like the common shape of a face. A great way to understand this is to look at the images you can get back out of neural networks that have been trained on like YouTube videos,
Hmm.
right? What are the artifacts that they find? And one of the artifacts looks like a cat, and one of the artifacts, you start to see kind of the types of videos that are on YouTube expressed as images, right?
Hmm.
Because there at some layer, you're getting to more and more layers of abstractions. You're eventually getting to the point where you have these really interesting abstractions. Like, is this a cat? Um, so I would say if your data went really wide, right, and your data had really subtle effects, then at that point, having basically more intelligence that you can train in the model, right? You can get to the nuances of the data.
Hmm.
But there's things that you could do instead of adding additional layers. Like you could tell it, hey, I want your random forest model or your XGBoost model to have more layers,
Hmm.
right? So you could do those kinds of parameters in each of those 12 models, or you could just add another layer.
Okay.
Uh, yeah, I guess my first cut would always be take the defaults,
Right.
because they're really good.
Hmm.
Like I said, the defaults have been chosen because the AutoGluon team, like they took the random forest model and they ran an enormous amount of data through it, and they found, okay, here's the settings that work best in general, right? So I would just start there as your baseline. And this thing is so fast, in training models for you that you could deploy that one to production. Okay, now you've got your experiment running. And then you can say, okay, well, let's try something. Let's just make that first layer, let's make it deeper, right?
Hmm.
Let's allow the random forest to be deeper. Let's allow XGBoost to be deeper. Let's do those kinds of things and just run that overnight,
Hmm.
right? And get a feel for, did our performance improve, or did it not? Um, and you can also try, let's try 3 layers instead of two.
Hmm.
Often people start off with just one layer because that works awful well and it's very fast. And now you've got, models you can just pick off the shelf and away you go. But
Hmm.
um, yeah, that was a good question. Um, and so I don't really know how to answer that without running a bunch of experiments.
Okay.
Um, in fact, there might be, I wouldn't be surprised if there were some research papers where people had tried those kinds of variations.
Mhm.
So maybe I would start an archive and just see like, what have people tried and how well did it work?
Yeah, I'll take it out. Listen, anytime I ask a question where the scientist says they need to run some experiments, I think I'm winning, John.
Yeah, yeah, you got into an interesting area for sure.
Yeah, no,
Absolutely.
and I find it fascinating, right? Because as you start thinking about building additional layers up to find, for more abstraction, I start thinking about some of the more difficult. Yeah, like one of the more difficult cases I always think about when it just comes to utilizing AI is automated driving, right? On
Mhm.
countless applications from either trucking to taxis, buses, what have you. Lots of
Wheelchairs,
applications. I'm sorry.
wheelchairs,
Oh yeah, that's a
right?
great one, right? I didn't even think about that one, but like
Yeah.
all of that is amazing. But I think it's always been explained to me that you can't right now our current architecture and current models just don't have the ability to process that many edge cases, and so yeah, I just start thinking about building different layers on top. But then it's can it process that information as quickly as is needed in a situation where you're in a car and there are lives on the line.
Yeah, yeah. Oddly enough, I think landing an airplane is a lot easier than driving a
Yeah,
car.
there's a lot
Um,
less variables. You can't.
yeah.
It's a lot harder to hit something in a plane. Outside of the ground, right?
Well, I mean, you have the advantage with airplanes of saying you're not allowed to land in Denver,
Hmm.
right? Denver's a mess. We're going to send you someplace else. You can't land in Denver. Whereas in a personal vehicle, you don't have the option of telling the driver you can't get eggs today. Like,
Hmm.
yeah, we're not driving today. Uh,
Hmm.
People would just want to accept that. Um, yeah, so AutoGluon doesn't work for those kinds of things, right? That's where you do need a neural network um, and an advanced architecture. Um, but definitely the idea of the complexity of having all of those different models in that ensemble
Hmm.
is intended to help you to find and do the right thing in all those kind of edge cases and nuances.
Yeah, and John, in your experience, what are some of the common misconceptions out there as it relates to auto ML and how is it well known within the community?
Yeah, I think at least my own personal experience was I just couldn't believe that it would work because I hadn't taken the time to kind of look into what they were doing.
Hmm.
Right. Once you understand kind of what it's actually doing, I think it's pretty easy to believe that, okay, this probably will work because all they did was kind of script the process that I would go through, right?
Hmm.
Um, and so the other big problem is, yeah, people don't know about it,
Yeah.
right? They're spending a lot of time writing in low level, like in TensorFlow and those kinds of things. Um, and they just don't realize it's there. Another misconception is that they're not using it because, like I said, if you're on AWS and you're using one of these tools where you upload your data and get a model, that is AutoGluon.
Hmm. Yeah.
Um, the the other thing is that it might be really expensive, and in my experience, it actually isn't very expensive. Um, because a big expense is always the people that are involved.
Hmm.
So if I take someone who's making my salary and a team of four of me over a 3 month period, and I compare that to running something overnight, it's pennies. It's so cheap.
Hmm.
Um, so I do think that there are. Um, I mean, I definitely saw this. It was an existential crisis for me. I looked at this and I thought, oh my goodness, like they just automated like 90% of my job.
Hmm.
Um, and so I think there's scientists can have this experience of, well, we probably shouldn't tell people about this. Like, um,
Self-preservation.
yeah, but you get over that pretty quickly because you realize that, it's doing the stuff that is not interesting,
Yeah. Hmm.
right? And so I can use my expertise to improve the rest of it and understand the data better and understand the performance better. And then I can go work on stuff that's more interesting, like generative AI and neural networks and those kinds of things, for which there isn't, something like AutoGluon yet.
What are the barriers to that? And why isn't there something like an auto glue one for that not yet?
Well, AutoGluon, they do have some neural networks as one of the models,
Hmm.
but um, okay, something like uh, OpenAI's model, it's not just a neural network. It's not something where you say, okay, we're gonna have this many neurons on each layer. We're gonna have this many layers. Go. It's much more sophisticated than that. So, like the way that those models handle attention and decisions about how we're going to manage attention, that's really sophisticated. So, the neural network is a building block that you're combining in different ways to get to the final solution. Um, and so remember when I started my story, I said there were kind of two ideas about how to automate machine learning.
Hmm.
The AutoGluon team took the throw spaghetti at the wall, just try everything.
Hmm.
There were these other teams that were like, no, let's have the machine kind of look at the data and look at the distributions of the features and look at the labels and kind of does figure out what type of model would work best, right? It was a lot more what a scientist might do to use their intuition,
Hmm.
right? It's like I understand how these things tend to work out. I understand what tends to work better, right? So it was kind of a cognitive approach where this is a kind of brute force approach.
Hmm.
Um, the um, neural networks. So if you're trying to do something like generative AI, um, there aren't really good there there aren't really good building blocks, um, I think, that work like AutoML kind of does, where it's like we could just throw these things to the wall and see what happens. Um, Partially because the amount of data you're using is so gigantic, right? That you need to be thinking about efficiency kind of all the way along.
Hmm.
And you might make decisions to use something because um, it's going to save you a couple $1 million, even though it might have a negative impact on overall performance because you figure you can catch up the performance difference with something else later, right? So there is a whole lot of kind of, well, I'll give you a simple example. Um, OpenAI clearly has a great product on their hands, right?
Yep.
And we have other companies like Anthropic, they have a great product. Google has a great product, right? If you look at what's going on, it's not that they have more money,
Mhm.
right? Like Apple has a huge pile of money,
Yeah.
right? Amazon could apply, well, is applying an enormous amount of money to the problem, right?
Mhm.
And yet, these initial leaders have what appear to be a pretty significant advantage over everybody else. And if you look at why, it's because, oh, they are the people that have been working on this problem with transformers for the longest time. Like you have this core group of people that were primarily at Google that split and went to these three companies. And
Mhm.
Amazon can't hire them away, and Apple can't hire them away. And they're off having a lot of fun. And it's because they have this intuitive understanding of what they're doing. They have so many hours of banging their head against the wall trying to get these things to work that, that's propelling them forward. You can't code that. If you could code that, then everybody's generative AI would basically be the same. Now, I would argue that eventually we get there,
Mhm.
right? Um,
Eventually.
yeah, because um, eventually people will move between companies, things will become commonly known. You've got efforts like Meta's model, which is open source, so you can see exactly what they're doing. You can't see the training data, but you can see exactly what we're doing. Apple did an interesting thing. They released an open source model with all their training data, right,
Mhm.
which is the real secret sauce of what's going on. Um, and so, yeah, I think eventually you get there, but by the time you get there, it may not be interesting
Yeah.
to
Mhm.
create yet another one.
Yeah. No,
Does that
and
make sense?
no, it absolutely does. It absolutely does. I think you're absolutely. I think by the time you can, it won't be interesting. It won't be the interesting problem to solve anymore. We'll be on to something else.
Yeah,
You
among other
know.
things, you can just ask it to,
Mhm.
I need you to create a generative AI model for me. And it's
Right.
like, okay, sure.
Yeah. Absolutely. Not a problem.
Ah,
I can make however many you want in whatever language you want. Right.
yeah,
Like, and that's the other part.
yeah,
And I do think though one thing that you're wrong about there, John, is that Apple has not been leading the way in AI. I think where Apple their major strides have been on the chip side. I think they've done a really good job of investing in chip technology over the last decade and have really led the way on the hardware side, less so on the end user's hands side and like as an end finished product yet as Apple Intelligence isn't out yet. I think that one of the things that I personally like about Apple as a company is that they do absolutely have a reputation of always being late and not always having the most cutting edge tech in their devices. However, they it all works together in a way, and their interoperability across platforms that, in my opinion, other organizations and other companies don't have, right? I can copy on my phone and paste onto my computer. Like I didn't know I needed that, but that's one of those little quality of life things where it's like I can't live without it anymore.
yeah.
Um,
If you look at Apple Silicon,
mhm,
um, their motivation wasn't AI. Like they made really good decisions about building um, the the GPUs into their CPUs, right? But
mhm,
the really great decision was just making the memory channels crazy fast and available, right? So
mhm,
you've got all the system memory essentially on the chip, right? So it's super crazy fast. But their goal was, I think if we went back and we look at like, if we had the meeting notes from when they were saying, hey, we're going to do Apple Silicon, and these are the reasons why, I think they would say, Intel's GPUs suck, we're losing in games.
mhm,
And the gaming market on phones is a big market, and the gaming market on our desktop is kind of interesting, but mostly it's on the phones. And so we need to figure out hardware that has GPUs at low heat
mhm,
and high performance. I think that was actually the reason. And then lo and behold, suddenly, well, the Siri guys were like, "Hey, we think we can do some cool things around photos if you just give us a couple neural
mhm,
pieces of hardware." Um, so yeah, they ended up in a really happy place. I don't think they had. Uh, I don't think they were prophetic,
mhm,
right? I don't think they saw GPT coming. Um, but they're lucky, right? They're really lucky. They happen to have, like you said, they've got great hardware.
Hmm.
which has got super fast memory that can work around the fact you don't have very many GPU cores.
Hmm.
Yeah, I agree. But on on the software side,
Hmm.
they're okay,
Yeah.
right?
Hmm.
They've got a huge amount of catch up to do, right? Siri is nowhere near ChatGPT, which is why they had to go license it, right? Um, um, and they on the software side, Apple does, if you go to Archive, Apple does periodically release a couple research papers, which are pretty interesting. And a lot of them are like, how do we get the AI small enough that it runs on a phone, right? They're very focused on phones. Um,
That's 60 something percent of their business.
yeah. And Apple has an enormous amount of cash. I mean,
Oh
one of
yeah.
the things that when I first got to Amazon years ago, uh, I was in the devices business, and we were
Mhm.
talking about these tablets that were coming out, and somebody made a comment about how our tablets are going to wipe out the iPad. And I said, Apple has enough cash. They just have enough cash that they could write a check and buy a controlling interest of Amazon.
Mhm.
And they're like, they didn't believe it, right? I mean, and that amount of cash has just grown and grown and grown. And so if they could recruit people away, like they could recruit the top AI people from OpenAI or from Anthropic, I think they eventually would,
Mhm.
because it turns out the people are what it are why these companies are making these enormous advances and why other companies are struggling or having a license from others.
Mhm. Yeah, absolutely. Do you think Nvidia was prophetic? Or did
Yes.
yeah.
Yeah. I think they knew what they were doing. CUDA was a really good idea. And it
Mhm.
was a really good idea a long time before anybody cared about machine learning.
Mhm.
Like that was brilliant. So there should be a statue to the people that were in that meeting that greenlit CUDA because um yeah, we wouldn't be where we are without what they did. The hardware is great, right? They've continued to make great hardware. Um, but the fact that it was really easy to build to use those GPUs for non-graphic things, brilliant. Absolutely brilliant.
Yeah, absolutely. Yeah, they great company. I have continually just been flabbergasted by their profit margins on their public reports like that are published. It's like they have like a 60% net profit, which is just I mean, that's just disgusting. Like nobody has that. No, like nobody runs at that kind of profit margin as an organization of that size. Like no, like that's unheard of. See, I mean, it's why they're the most valuable company in the world right now, or one of them. And it's incredible to see. And it's clearly a very, very well run organization. And absolutely fascinating to see kind of how all these different organizations have, either been preparing like Nvidia has or just gotten kind of lucky in some ways like an Apple has. And just really fascinating. Fascinating time, John.
Yeah, I think it's so Tesla's an interesting one, right?
So,
Well, because uh Musk famously went out and bought what like 100,000 H100s or something like that, right? He built a supercomputer in a very short amount of time. So kudos to him for pulling off that engineering feat. I mean, I don't know, maybe it's running at like 7,000 degrees inside there, but they did appear to get it up and running. The thing that I think something that people miss with Tesla is how much of their profit is due to selling EV credits to other car companies,
yep.
right? So if I was sitting inside of Tesla, one of the things that I would be doing is spinning up a group of people that were going to sell access to our supercomputer. Because you never want one of those things to ever be idle, right? You want it running 24 hours a day, as fast as it can, as hot as it can go, feeding it as much water as it needs, right? Because you've got this enormous sunk cost. And there's a window where all of a sudden the H100 computers aren't interesting at all, right? So you've got this brief period of time to make up all this money. Um, so similar to the EV credits, I wouldn't be surprised if they were turning around very quickly and trying to sell access to that supercomputer. Um, because I don't think I don't think they're going to get as much out of it as they want to get out of it. I don't think they necessarily have the people. Like it's the same problem. Like they don't have the OpenAI people. They don't have Anthropic. We haven't heard about top people from top companies rushing to get to Tesla to use this computer, right? And so um, it's going to end up being idle if they can't resell it. And reselling it to Oracle and kind of these other like second tier and third tier tech companies that don't really have a strong AI story, at a good price, yeah, that might be an interesting source of revenue for them.
Mhm.
But again, it's all NVIDIA hardware. And there isn't really, surprisingly, AMD and Intel haven't managed to figure out how to produce GPUs with something like CUDA that, are anywhere near what NVIDIA is doing or work as nicely with the existing frameworks as what NVIDIA already has.
Yeah. No, absolutely. And I think Tesla it's an interesting company just in general. One of the reasons that I was really interested in it 2017, 2016, 17, 18 when I started really doing research on it was their battery production tech, their battery production capabilities, right? I wasn't even interested in it for the car. I was looking at, all right, well, you look at things like, the emissions requirements in California and how that lead drives the nation and the nation's policy, because that's like 55 million people, and we have 430, so that's a huge percentage of it. And when people and companies are making cars, they're going to make them where they're not going to make them that they can't sell it in the biggest state in the country. And they, you look at the gigafactories that they have in California, and then I think they have another one in Austin. They have some overseas. They have huge abilities to make batteries in a way and at scale that a lot of organizations don't. And that was really interesting and attractive to me. Then and it's paid off for me. But it's also really interesting, I think, to see how like the cultures of organizations and how that affects talent attraction and retention, especially in a spot like this where there are a very finite number of people that have this level of expertise.
Right.
You know, It- I don't know if they'd want to go work for an Elon Musk in one of those organizations, having heard some of the stories that I've heard about folks from either that used to work at Twitter or worked at his organizations, whether SpaceX or Tesla or any of the other ones. I don't know.
Yeah, I mean, I think everybody in Silicon Valley, I was in Silicon Valley for quite a few years, and I think everybody had a soft spot in their heart for Twitter,
Hmm.
right? It was a valuable source of like all kinds of just random news, right? It's like, where is the taco truck, right? I
Yep.
mean, Twitter was how you found out where your lunch was.
Hmm.
Um, and so I think we all, and then I think we also recognized that uh, Twitter hadn't been making a big play to make a ton of money.
Hmm.
Right? It felt like Twitter was, um, I mean, maybe they were incompetent at making money, but it also felt like they kind of had ulterior motives. That there were other things that they were interested in besides just making a giant pile of money.
Is there?
Um, yeah, so everybody kind of had a soft spot in them. They were kind of one of the good guys. Yahoo was a similar case. It's like when Yahoo got sold, I was at Google, and everybody was sad
Hmm.
because we all had a soft spot in our heart for Yahoo.
Yeah.
And we really respected their research department. They had excellent researchers, and all those people immediately were gone
Hmm.
from Yahoo to other companies. Yeah, so watching Twitter get just eviscerated, um, yeah, I'm in no hurry to go work for X,
Hmm. Yeah.
right? Um, and I think there's a lot of really top talent that's in no hurry to go work for X because they can write a check anywhere and they can choose their boss. And once you figure out that you can choose your boss, that's a really powerful thing.
I agree.
Um, yeah, so kind of getting back to the federal government,
Hmm.
um, yeah, we have this. I think data.gov, I think, is a fascinating thing, and so far it's survived and it has some really interesting data in it. Models.gov, I think, would be a really cool thing. It's
Hmm.
like, if we have these models, especially built on data.gov data, and we can share those with the general public, I think there'd be an enormous amount of opportunity for people to learn more about machine learning, apply it in their lives, get used to these models, perhaps contribute back to the models. Um, there's we all get very distracted by the shiny thing, which is generative AI, because it is very impressive, right? Someone would say it's magical. Um, but most of my career has been about solving business problems that didn't require generative AI.
Hmm.
right? They weren't about text. They weren't generating text or they weren't generating images, right? Um, but they were super important. Like knowing how many sales we're going to make in 2 weeks is super important because it tells
Yep.
me how many drivers we're going to need in 3 weeks. It tells me how many people need to show up for work, right? It tells me, do we potentially need a new FC fulfillment center? It's like
Hmm.
um, knowing like how many accounts were created today that were solely created to try to abuse a seller,
Hmm.
right? Or commit fraud, super valuable, right?
Hmm.
And I'm not going to go to I'm not going to go to ChatGPT and ask those types of questions because it can't help me, right? But I would say 90% of a business's business or a government department's work is more in the realm of auto ML, right? And not necessarily to provide the one true answer, but to provide people with kind of guardrails.
Hmm.
It's like our prediction is it's going to be between these two numbers, and your human intuition and experience can be guided by that, right?
Hmm.
The probability it's outside of those is very small, and so here's where you can make the most value and uh, get stuff done faster and easier. And I think that's an enormous blessing.
Absolutely. I couldn't agree more. I think that, how, again, speaking for myself personally, how I've used AI is it's allowed me to focus my brain power on things that I actually need to think about, as opposed to, writing every single word of every single piece of content that ever goes out, or, I mean, you can name it, but like
Yeah.
as a small business entrepreneur, as a small business owner, serial entrepreneur running multiple organizations, John, like my two biggest resources are my time and my ability to pay attention and my brain power on a daily
Yeah.
basis.
And
And
so, we got these large language models, but where the real improvement to your productivity is going to come from large action models, where the model can open a browser, go to a website, click on things, fill out forms, upload things, download things, like automate your workflow.
Mhm,
And so the things you were talking about, you were still clicking and pointing and using your personal time to do that kind of stuff. But,
mhm,
with a large action model, that part of your job goes away, right? You become a manager of multiple AI models that are automating your workflow. And you already have that in video. Like there's AIs that will like cut the video for you, make it easier for you to edit, um, produce shorts, for different video services on the fly, do color correction, all that kind of good stuff, right?
mhm.
Those large action models are what is really going to be super powerful in terms of automating the lives of a lot of people doing a lot of things. And if you could fold into it, things like AutoML, where the model can see, oh, in order to make a good decision about this, I need to make a prediction about where we're going to be in 2 weeks. And so therefore, let me gather some data, create a little model, and start to predict where we're going to be in 2 weeks. That's when everybody just becomes a lot more efficient.
Yeah.
And, being more efficient means you have fewer things in warehouses, you've got fewer unsold things, you hire the right number of people, you hire people just in time, like all those good things start to happen, which uh, is a real blessing for any organization or company.
I mean, the thing I'm begging for and just thinking about. So I started Robots and Red Tape 7 months ago or so on a whim. When I recorded the first one, John, I hadn't even named it Robots and Red Tape yet. But I didn't realize, and I didn't realize how much work goes into just like posting different
Right.
clips
Yeah.
and shorts and videos, whether it's on Instagram and LinkedIn and Facebook and YouTube and all this stuff. Dude, if I could just literally take a YouTube video and say, "Hey, clip this up and post it across these accounts." In whatever time frame and post it at whatever times you need with the proper, hashtags and everything, that would save me hours a week. And it would also destroy the social media marketing careers, which for a lot of people. But like that is just because it's not even interesting work. It's not difficult work. It's mind-numbing BS that you just have to do. And it's just a time suck. So,
Yeah.
but
I imagine there were people who went home to their family Thanksgiving And when grandma asked, "What do you do for a living?" they said, "I choose hashtags,"
Hmm.
right? And um, first of all, it probably really confused grandma. But who knows? Maybe she's very hip.
Yeah.
But um, I've had lots and lots and lots of different kinds of jobs in my life, right? And I usually moved on to a more interesting job that I learned new things and was more fulfilling and usually paid better. Um, Picking hashtags, good job right now. You know, if you have that job, good for you. Um, but it probably, yeah, like you said, it's probably a job that's going away. I mean, it's pretty easy to hand a transcript to a model, even a local model. Like I mostly use models that run on my own hardware in my house. Hand it to a local model and say, yeah, give me some ideas of the hashtags that'll work well to blah blah blah. And okay, that job's also automated.
Yeah.
Um, but that's not the interesting creative part.
Mm-mm. No, this
Um,
is.
and chasing down people to be on your podcast and following up with them and rearranging schedules, that's probably not your favorite part of the job, right?
Mm-mm.
That's not what you told your grandma you do at Thanksgiving, right?
No.
Um, so yeah, I think AI, there's a lot of reason that people are scared about, it's going to eat my job. I think the way I think about it is everybody eventually has an executive assistant that, man, if I could take someone, give them an executive assistant, and they're 5 or 6 times as productive, that was a really good thing,
Yeah.
right? And I think that ends up being kind of the goal
Yeah.
because uh, if you replace everybody who has a job, you have no customers.
Hmm.
That's no good. That doesn't
No.
do anybody any good,
Mm-mm.
right? And so the right aspects are just making everybody's jobs more fulfilling, more interesting, and just something you can be really proud of when you talk to grandma.
Absolutely. Absolutely. Yeah, no, I appreciate that, John. You're absolutely right. And it'll be interesting to see what happens over the next couple of years. Yeah, but before we wrap up, sir, just anything else you want to add? Any other points you want to make? Anything that I missed?
Oh, well, feel free to find me on LinkedIn. I've got a button there you can click for us to spend 15 minutes together just talking about whatever you want to talk about. It's free. I enjoy talking to people, finding out what they're doing. One of my favorite parts about uh, working at Amazon as a AI researcher was all the different kinds of parts of the company I got to meet. From people that are building drones to people that are trying to make lives better for our drivers and people that are preparing food. Is like I love those field trips into what people are doing. And usually we could find something that they could deliver using machine learning in a fairly short amount of time that could have an impact on them. Because my experience is that if you go to management and you're like, hey, we had this small win, and now we want to go after this medium win, and then we want to go after this large win, those are the projects that tend to get approved and supported and funded. And um, I enjoy helping people figure out those things.
I love that, John. I really appreciate you coming on and sharing your expertise and teaching me a lot about, auto ML and how it differs and why it's such a game changer in this space.
Yeah, yeah, it's super cool. Nice to meet you.
Nice to meet you. Thank you for listening to Robots and Red Tape, everybody.